Okay, so you are going to find the convolution of the following sequences. That is, x of n is given and h of n is also given. X of n is u of n and h of n is 2 raised to n u of n. Okay, in a convolution, there are two methods to do convolution. The first method is by following the equation only. You can just write the equation, you can solve directly in the equation itself. Next method is called a graphical method. So we will be covering the method using simplification of the equation here. Okay, so you can write the equation first. Please everyone write the equation. The equation is y of n is equal to sigma k is equal to minus infinity to plus infinity x of k multiplied by h of n minus k. This is the equation for convolution. So we are given what is x of n. So if x of n is given, you can simply write x of k, it is u of k itself, isn't it? And you are given h of n also, it is 2 raised to n u of n. But here what you require is not simple h of n, you require h of n minus k. H of n minus k is what is required. So what is h of n minus k? Here instead of n, simply substitute n minus k. So it will be 2 raised to n minus k u of n minus k. Isn't it? So please substitute that in the equation. What you will get is y of n is equal to sigma. Here the limit is starting from k is equal to minus infinity to infinity. Isn't it? But here I will write that equation itself. K is equal to minus infinity to plus infinity. Instead of x of k, it is u of k. And instead of h of n minus k, it will become 2 raised to n minus k u of n minus k. Now, this is the first step. Then what you have to do is you have to change the limit. Okay. How do we change the limit? You can change the limit by substituting the value of this u of k. You all know that u of k is a unit step signal. So for a unit step signal, the value is 1 and the range is from 0 to infinity. The unit step signal exists only from 0 to infinity. So if you are substituting a value for this u of k, if you substitute the value of u of k as equal to 1, then you can simply change the limit from 0 to infinity, because this signal u of k is existing only from 0 to infinity. So it is as simple as that. Okay. So minus infinity തുടങ്ങി plus infinity എന്നുള്ള equation 0 തുടങ്ങി infinity വരെയായിട്ട് change ആയി. u of k യുടെ value 1 ആയി into 2 raised to n minus k. I am placing this u of n minus k as such here. കാരണം അടുത്ത സ്റ്റെപ്പിൽ നമ്മൾ u of n minus k യുടെ വാല്യൂ 1 ആയിട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. ഓക്കെ, എങ്ങനെയാണ് അത് ചേഞ്ച് ചെയ്യുന്നത്? അത് ചേഞ്ച് ചെയ്യാൻ ഈസിയാണ്. നമുക്കറിയാം നമ്മുടെ u of n എന്ന് പറയുന്ന സിഗ്നലിന്റെ വാല്യൂ 1 ആവുന്നത് എപ്പോഴാണ്? u of n is equal to 1 for n greater than 0. Isn't it? Then u of n minus k will be equal to 1 when this value, that is n minus k, is greater than 0. Okay, so u of n minus k is 1 for n minus k greater than 0, because u of n is 1 for n greater than 0. So from here you can simply write as n greater than k. Just put this minus k to the right side, it will become plus k. So n greater than k. So u of n minus k is 1 for n greater than k. N greater than k. So you can simply change the limit in this equation. What is the limit in this equation? Here k is varying from 0 to infinity. But here what it is saying that k is less than n. Okay, k is always less than n. So does it end till infinity? No, infinity വരെ അത് പോവില്ല. കാരണം എന്താണ്? k യുടെ വാല്യൂ ലെസ് ദാൻ n ആണ്. k യുടെ വാല്യൂ എപ്പോഴും ലെസ് ദാൻ n ആണെങ്കിൽ ആ മുകളിലത്തെ വാല്യൂ എത്രയാകും? k will be equal to 0 to n only, because your k is less than n. Okay, so our limit 0 to infinity now became 0 to n. Okay, k is equal to 0 to n. K is equal to 0 to n. Then inside what will be that? 2 raised to n minus k. Isn't it? So our equation now changed like this. Now here we can see that the variable is k. Variable k ആണ്. K is varying from 0 to n. So this n can be taken as a constant. It can be taken outside. So this is equal to 2 raised to n into sigma. K is equal to 0 to n 2 raised to minus k. Now you keep values for this 2 raised to n into 1 plus then 2 raised to minus 1 plus 2 raised to minus 2 plus etc. up to 2 raised to minus n. Okay. Now this became in the form of a general equation. And what is a general equation? That we already know that general equation, we have studied it. The general equation is 1 plus a square plus etc. up to infinity. That is one equation. That is equal to 1 divided by 1 minus a. But here it is not extending till infinity. If it was infinity, it is 1 by 1 minus a. But here the equation is 1 plus a square plus etc. up to a raised to n. And that equation is 1 minus a raised to n plus 1 divided by 1 minus a. Okay, we need to study only these two equations for solving all the questions. Okay. So 1 plus a square up to a raised to infinity is 1 by 1 minus a. 1 plus a square up to a raised to n is 1 minus a raised to n plus 1 divided by 1 minus a. So you can simply substitute that over here. And I think you'll be able to do that yourself. Please try to do this yourself. So just apply that equation. What is the equation? 1 minus a raised to n plus 1 divided by 1 minus a. 2 raised to n already പുറത്ത് കിടക്കുന്നുണ്ട്. So just place that 2 raised to n there. And 1 minus a raised to n plus 1, isn't it? ഇതിനകത്ത് a എന്ന് പറയുന്നത് എന്താ? 2 raised to minus 1 ആണ്. Isn't it? 2 raised to minus 1 എന്ന് പറഞ്ഞാൽ actually 1 by 2. 1 by 2 ആണ് 2 raised to minus 1 അല്ലേ? അപ്പോൾ 1 by 2 raised to n plus 1 divided by 1 minus a, isn't it? 1 minus 1 by 2. So again 2 raised to n divided by, what is 1 minus 1 by 2? It is 1 by 2. So 2 raised to n divided by 1 by 2. 1 minus 1 by 2 raised to n plus 1. So what is 2 raised to n divided by 1 by 2? 2 raised to n divided by 1 by 2 എന്താ? ഒന്ന് പറഞ്ഞേ. പറയുന്നില്ലായിരുന്നു. So this is 2 raised to minus 1. This will go upside and it will become 2 raised to n plus 1. Okay, 2 raised to n plus 1 പുറത്തുണ്ട്. Then again inside you are having 1 minus 1 by 2 raised to n plus 1. Ivideയും raised to n plus 1 doesn't matter, isn't it? So what will be this? Take this 2 raised to n plus 1 inside, you will get it as 2 raised to n plus 1 minus 2 raised to n plus 1 by 2 raised to n plus 1. That is 1. So this is 2 raised to n plus 1 minus 1. Isn't it? Or you can say that this is equal to 2 raised to n into 2 minus 1. Why I am writing like this is that I will be writing this y of n. This is your output, isn't it? So you will be always representing the output in terms of input only. Output നെ നമ്മൾ എപ്പോഴും ഇൻപുട്ടിന്റെ ബേസിസിലാണ് എഴുതുന്നത്. അപ്പോൾ നമുക്ക് ഈ 2 raised to n into 2 എന്നുള്ളതിനെ ഒരു u of n വെച്ചുകൂടി മൾട്ടിപ്ലൈ ചെയ്യാം. Because your signal value doesn't change. u of n ന്റെ വാല്യൂ 1 തന്നെയാണ്. അപ്പോൾ അതിനെ 2 raised to n into 2 വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യുന്നത് വഴി അതിന്റെ വാല്യൂ ചേഞ്ച് ചെയ്യുന്നില്ല. മൈനസ് അഗെയിൻ ഇവിടെ ഒരു 1 ആണ് അല്ലേ? ഇതിനെയാണ് മാറ്റി എഴുതുന്നത് കേട്ടോ. മൈനസ് 1 ഉള്ളത് വീണ്ടും ഞാൻ ഒരു u of n തന്നെ എഴുതുന്നത്. Okay, because the value of u of n is 1. Only thing is that n should be greater than 0. നമ്മൾ ഓൾറെഡി നമ്മുടെ ഇക്വേഷൻസിൽ എല്ലാം n greater than 0 ആണ്. So you can simply replace like this. So this will be the general representation of the signal. General representation of this ഔട്ട്പുട്ട് ഓഫ് ദ സിഗ്നൽ. അപ്പോൾ y of n എന്ന് പറയുന്ന ആ ഒരു സിസ്റ്റത്തിൻ്റെ റെസ്പോൺസ് എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് ഈക്വൽ ടു 2 raised to n into 2 into u of n minus u of n. Okay, this is the convolution sum of the signal. Now I will give you one question which you can try to do by yourself. The same method you can follow. X of n is equal to, this is the second question, you can note down, x of n is equal to e raised to minus n square and h of n is equal to 3n square. Okay, x of n is e raised to minus n square and h of n is equal to 3n square. So you are asked to find the convolution. So the basic and the first step in every question will be the writing the non-equation. So we know the equation here. Y of n is equal to sigma k is equal to minus infinity to infinity x of k into h of n minus k. So I am going to substitute now. So instead of x of n, I will substitute x of k there. അപ്പോൾ n ന് പകരം k എന്ന് കൊടുക്കുക. So it is k is equal to minus infinity to infinity e raised to minus k square. And instead of n in 3n square, it will be n minus k. 3n minus k the whole square. Isn't it? So I can write a minus b the whole square equation there. വേറെ ഒന്നും സോൾവ് ചെയ്യാനില്ല. അപ്പോൾ സോൾവ് ചെയ്യാൻ വേറെ ഒന്നും ഇല്ലെങ്കിൽ you write whatever you know. So it is e raised to minus k square into 3 into 3 ഞാൻ അകത്തെടുത്ത് തന്നെ ചെയ്യാം. 3n square minus 2ab that is 6nk plus b square that is 3k square. Now n is a constant when we compare it to this k. So that n can be taken outside, also k 3 can also be taken outside. That is 3n square into sigma k is equal to minus infinity to plus infinity e raised to minus k square plus next term 3 into the last term is 3 into k is sigma k is equal to minus infinity to infinity into e raised to minus k square into k square plus minus 6 and n is a constant, take it outside, sigma k is equal to minus infinity to infinity k e raised to minus k square. So this is the answer. ഇത് ഒറ്റ സ്റ്റെപ്പിൽ തന്നെ എഴുതാം, സ്ഥലമില്ലാത്ത കാരണം താഴേക്ക് എഴുതിയതാണ്. ഓക്കെ, സോ ദാറ്റ് ഈസ് ദ ആൻസർ. ഇനി അത് ഫർദർ സിംപ്ലിഫൈ ചെയ്യാൻ സാധിക്കില്ല. ഓക്കെ.